So today's lesson, we're looking at recurrence relations that are modeling growth and decay. So an example of this is like if you get a home loan, and obviously the bank's going to charge you interest on borrowing that amount. So the total that you owe goes up. But the decay part are your payments. So you've decided to pay the bank, $1,000 every 2 weeks to pay this home loan off. So that is the decay. So we're going to see when they're combining both of them. So this first example, we're going to look at geometric linear growth and decay. So geometric is when you're timesing by the same amount. So see, if we times our amount by 8% every time, that is a timesing, so it's geometric. So it's arithmetic is when it's the same amount. So it'd be like $10 every time. This one's not going to be, it'll be a different amount, but it's 8% every time. Okay, so the following recurrence relation. So recurrence relation just means the rule when they write it with this language, like with like the VO and the N+1. That's all that means when they say that. So the following recurrence relation can be used to model compound interest. So here you go. Compound is an example of geometric investment of $1,000. So their original loan was $1,000 and paying an interest rate of 8% per annum. So here they're showing you. So use the recurrence relation to find the value after 3 years. So this is when you go in your calculator and you just pop 1,000, press enter, and then remember do times 1.08 and you'll get press enter, and then you end up with 180, and then we can keep pressing enter like we did, and we'll get 1166.4 and 1259.75. So this is after 1 year, 2 years, 1.08. Because this is the rule up here telling us how to do it. So, all right. So when will the investment reach 1,500? You can keep pressing enter if you like, because you're nearly close to it. So if we kept pressing enter after our answer, we'll get 1360.49, then 1469.33, and then we'd end up with 1586. So we've gone over 1,500. So this was V4, V5, V6. So it's on the 6th term or the 6 years. So the investment will will first exceed, so just write it out, 1,500 after 6 years. So we're somewhere in the 6 years. Okay, so here's an example of we are going to do the nth rule. So remember, just before we were doing a recurrence relation. So a recurrence relation is when you have that N+1 formula and you've got to keep just getting the next term from the one before. When you use the nth rule, that's a formula to find any term at any stage. And remember when I said, I asked you to say what's happened after 100 terms, that's going to take forever on your calculator. We wouldn't ideally want to be using that. So that's when we're going to start using this nth rule formula. So this is our nth rule formula here. So you need to know what the big R is. And the big R is when you do, if it's growth, it'll be 1 plus the interest rate over 100. So say before it'd be 1 plus 8 over 100. If it's decay, so say something's depreciating, you do 1 minus the interest rate. So, and in VO in the formula is always what you originally began with. So we just looked at back here, times a couple of examples here. So a car was purchased for $18,500. So there you go, that would be VO. The following reoccurrence relation can be used to model the car's value as it depreciates by 10% of its value each year. So see here, this was R. So can you see how they calculated the R by going 1, because the car is depreciating, it will be 1 minus 10 over 100. So can you see that equals 0.9? And that's there, isn't it? That's how they found that. Okay, so this is the formula. This, when it's written out like this, see with the n plus 1, that is a recurrence relation. Okay, so if they ask for a recurrence relation, they want you to write it out like that. So now they said use the rule to find the value of the car after 12 years. So I'm going to pretend I don't want to keep clicking the button for a long time. So I'm going to use the nth term formula. So we go Vn equals R to the power of n times VO. All right. So we want to know after 12 years. So we want to know V12. We know R is, so I'll just point that out to you. R is this number here, the 0.9. So I'm going to do 0.9. So what's n in this case? Because I've changed it now, 12, good, times VO, which is 18,500. Okay, you just pop that in on your calculator. No, just type, you only have to type this bit in, and then you just get 5224.90. And it said to the nearest dollar, so I'm going to make sure I write so I might just state my answer over here. So I'll go 5225, and I'll put a box around it so that examiner knows that's your final answer. Okay, when will the car be worth 1,500? So that's like that's the value. They've given you the value, and they sort of want to know when. So that means n is the question. So if using my nth rule, so my nth rule would actually be 0.9 to the power of n times VO. So we're trying to find when is the value 1,500. N's the question, so I don't know that. And I'm going to VO, I know. So this would be a case where we're going to use solve. Okay? Comma n. And you'll get that n equals 34.27. So at 34.27, it has not, that's when it's reached 1,500. So you can't round down to 34 years because it wouldn't have reached it there, wouldn't it? So in these cases, when will the car be worth 1,500? Just when you're rounding, you'd say 35 years. So you're going to say after 35 years. Yeah, but I just said if you're at 34, it hasn't reached 1,500. And that's why. These are the cases where you have to just go over. Gotcha. So they'll get you on those ones because it shows you understand what the whole thing means.